you guys can complete the 2 warm-ups at the top of the notes, asking you just to name some angles. Bless you. All right, who can tell me how they named angle 1? Marquise?
Angle AOB.
Very good. Angle AOB.
And angle BOA.
Very good. Angle BOA. Remember, to name an angle, you have to use the vertex as the middle letter. So AOB or BOA. Very good. Question 2 says, if angle 1 is congruent to angle 2, name the bisector of angle AOC. So what would be the bisector? What is cutting it into 2 congruent parts? Ethan?
Ray OB.
Perfect. Ray OB. Remember, when you name a ray, it has to be by the end point, which is the starting point, and then any other point that's on it. All right, so a big chunk of the front page of the notes is not writing anything, it's just looking at the properties. Okay, so in geometry, we accept postulates. Remember, postulates were something that, an accepted statement of fact, and I call them geometry laws. So we accept postulates and definitions to be true. So some of you have been wondering, why do we have vocabulary on every test and every quiz? Well, today you're going to use the definition of words that we've learned so far in proofs when we're justifying something step by step. Now, something else you can use when you're doing reasoning in algebra and geometry are properties, which I kind of just touched upon with the bell ringer. These properties right here, you probably use, well, you do use all the time, but you just don't realize it. You just think of them as inverse operations. And you know, if you see addition, you do subtraction, and you do it to both sides, right, of the equation. That's what these properties tell you. So the addition property says that you're allowed to add a number to both sides and not change the value. Subtraction, you can subtract a number from both sides of an equation and not change the value. Same with multiplication and division. Now, the next 3 you probably don't know. So let's just put a little stars by them because we'll have to memorize them. So the reflexive property of equality literally just means that something is equal to itself. Like 2 is equal to 2, 3 is equal to 3, x is equal to x. Okay? Sounds silly, but it's called the reflexive property. When we'll use this is when we see shared sides in a triangle. So if you have 2 triangles, do you see how this side is shared between the left triangle and the right triangle? We would be able to say that like segment AC is equal to segment AC because they have to be the same length, they're the same segment. Does that make sense? But we'll get there a little bit later. One way to remember that one is like when you look in the mirror, you see yourself, reflection, so reflexive. Symmetric property, you actually used all the time in Algebra 1. If you were to get an answer like 2 equals x, your algebra teacher probably made you flip it around, right? Make it x equals 2. That is the symmetric property. It tells you that you're allowed to flip things from either side of the equal sign. Okay. Transitive property. Transitive property is kind of like the law of syllogism a little bit. So it'll have 2 things. If A is equal to B and B is equal to C, then you can say A is equal to C. So kind of like how we've had P to Q, Q to R, P to R. It's just this is used without statements and sentences. So we could use it with numbers or variables. Okay, the substitution property you do know from algebra. Once you get an answer like x equals 2, you can substitute 2 in for x and then solve for y. And the distributive property we should all know, where we multiply a binomial by a number or a variable, and we just distribute it into that sum. Okay. So below, we are going to justify, and you can see this is the start of a proof. Sometimes there's a line down the center, sometimes there's not. But what we'll be doing in a proof is you literally will be solving something. You will be justifying everything with a theorem, a postulate, or a definition. Okay, we'll start off with an algebra one, just because it's something you already know how to do. Then we're going to add in geometry. So And again, this is all about reasoning and justifying. So it's almost like you're a geometry lawyer, and everything that you tell me or say has to be backed up with something that we accept to be true. Okay. So today we're going to be justifying each statement that we make with a postulate, a definition, or a property. We'll also add in theorems later in the year, but we aren't there yet. Right now it's one of those three things. Now, what can confuse students in proofs is that what you do to get from line 1 to line 2, you write on line 2. Some people think you would write it on the line that you're doing it. So it's kind of like always delayed one step. So usually the first step is something that is given to you. Sometimes you'll have to write given, sometimes it'll be written for you, so you don't have to do it every time. But this was given to me, so I put that in step 1 and I say given. Now, normally you'll be solving this on your own, but I've solved it for us, and we're just going to justify each step that was done. So you kind of want to figure out, what did they do from this line to this line? What did they do to both sides of the equation to get that to happen? Maddie? They added 12. And you may want to write this in. Okay? So, what property allows me to add something to both sides? The addition property, and we will say of equality. Now, to shorten the writing, you can put addition property. You can abbreviate property with prop. And then instead of writing of equality every time, you can put of, and you can put a little equal sign instead of writing out equality every time. Okay, so again, what you did from line 1 to line 2 gets written on line 2. Now, from line 2 to line 3, what did they do to get from here to here? What did they do to both sides of the equation? Marquise?
Subtraction property of equality, they subtracted 1x.
Good, they subtracted x on both sides, so he is correct. That would be our subtraction. Now, be careful abbreviating subtraction, because substitution can be really similar to that. So I usually do write that one out. Subtraction property, and that is of equality because we're doing it on both sides of an equal sign. And then from step 3 to step 4, we can see that they divided by 4, which is the division property of equality. All right, now let's throw in some geometry. Now we know a lot of the problems that deal with geometry start out with a shape, and then we end up plugging in x's and solving it just like we do this. But we'll have a few steps to start us off. So example 2 says, suppose that points A, B, and C are collinear. What's collinear mean? On the same line. Point B is between points A and C, and then they give us a whole bunch of stuff. Well, I don't see a picture, so I'm thinking I need to draw this. So we have points A, B, and C are collinear. B is between. It's somewhere between. It's not necessarily in the middle because it doesn't say midpoint. So I'm going to have A, B, and C. Again, we don't know how close B is to A or C. It's just a sketch. Okay. Then they give us some information. Segment AB is 15 minus x. Segment BC is 4 plus 2x. And segment AC is 21. So this should look really familiar to chapter 1, right? It is. It's the same problem we did. But before I just said solve for x. Now I'm going to tell you to solve for x and justify each step. Okay, so this is adding in the reasoning through geometry and algebra part. Now you'll notice that I did put the given on line 1 for us. Now, when you do a geometry proof, you have to start with geometry. You can't go straight to writing the equation like we did in chapter 1. Okay? You are literally explaining, it's when you do a proof, it's like you're explaining it to like a, I don't want to say a kindergartner or something because they wouldn't understand, but like someone who's never seen geometry before, like a friend that hasn't taken geometry yet. You are to explain them step by step like you're teaching them how to do it, You would need to justify every single thing. Okay? So, the first thing I have to start with is the geometry. I have segments. What can I do with segments? What's a postulate we learned with segments in chapter 1 that allowed me to solve this problem? It's called the blank blank postulate. We're not sure. Let's go back into our chapter 1 notes. Section 1.5. Yeah, 1.5. Marquise?
Segment addition postulate.
Good. The segment addition postulate had said you can add a small segment plus a small segment as long as they're connected, collinear, and set it equal to the total segment. So that's what we're going to do. We're going to say that we can add segment AB. Now you don't need to put a segment bar on it because we're going to use an equal sign and not a congruent. So AB plus BC is equal to AC. Our justification is what Marquise just told me. I'm allowed to add segments because of the segment addition postulate. Now if you have a geometry proof, you have to start with geometry. You'll end up getting to algebra, but you have to start with the segment part. This is the line that a lot of students will forget to write in their proof. And then they'll be one line short. All right, now I can take what I know. AB is 15 minus x. BC is 4 plus 2x. And AC is 21. I have to justify. What do you think allows me to do that? Yes, we substituted values in. So if we go back to our property list from the front, this is our substitution property of equality, which says we can substitute things in when we know they're equivalent. Okay? It's our substitution property of equality. Now, from here on out, it's an algebra problem, just like the front. So the first thing we would do is we would combine like terms, since we have some stuff going on the left. Okay, now when you combine like terms, that's not actually your justification. Your justification will just be simplify. Now it's said simplify because you're not doing something on both sides of the equal sign. So you're not using a property of equality. You are just combining. So 15 plus 4 is 19. Negative 1x plus 2x is plus 1x. So see how I didn't move anything from the left to the right? So I'm not using a property of equality, just write simplify anytime you're just combining things. And then to solve for x, what would I need to do to both sides? Solve for x. Luke?
Subtract 19.
Subtract 19. And we'll get x equals 2, and that was subtraction, so that is our subtraction property of equality. It helps if you do both parts as you go. Some students like to try and do this whole thing and then justify it. I'm going to tell you that it makes it harder. If you do something and write it, it will make it easier for you. Okay. All right, let's look at another one. We have angles. So first of all, they do give us angle AOB is x, angle BOC is 2x plus 10, but they did give us this part. We need to add that to the picture. So angle AOC is the whole one is 139 degrees. Sometimes they don't put everything in the picture for you. At least they gave us a picture though, right? All right, now, given is already stated for me. Since this is a geometry proof, my first line that I write, which is on line 2, has to be in geometry terms. What can I do with angles similar to what I did with segments, to help me solve this for x. Marquise?
Angle AOB plus angle BOC equals angle AOC.
Good. I can add this angle plus this angle and set it equal to the total. Now, when we do this, we will use the measure of angle AOB. So we'll write the measure of angle AOB plus the measure of angle BOC will equal the measure of angle AOC. So again, you have to use the geometry first, then you can substitute in the algebra, and from there it'll be an algebra proof. What allows me to add angles? That's
The angle addition postulate.
good. I added angles together. That's my angle addition postulate. And I do have a sheet that has like all the properties, definitions, and postulates all in one paper for you to kind of like study off of and look at. All right, now substitute in what you know. So angle AOB is x, BOC is 2x plus 10, and AOC is 139. Again, you substituted, that's the substitution property. See if you guys can finish the proof. And we'll come back together, or maybe we'll pair share actually. And I saw a lot of it as I was walking around getting 43. Just make sure that you did justify it properly. So step 4 should be simplify combining like terms. Subtracting 10, and if you guys need to show this, I don't care if you have, you know what I mean, show the work and the proof. You're allowed to do that, as long as it's kind of smaller so it doesn't stick out too big. Subtraction property, again, some students get confused because they're like, I subtracted up here, shouldn't I write this here? It's always like a delayed line, okay? And then, of course, division, 43. All right, let's try the last one, and then the last thing we're going to do is just identify some properties. They'll give us some statements. This one is the hardest one, okay? The reason that this one is the hardest one is it does give us some words, okay? Anytime you're given words, midpoint, segment bisector, angle bisector, guess what you're going to have to do with that word somewhere in the proof? Define it, okay? You're going to have to use the definition of this word. Somewhere in the proof, okay? Anytime you see a word somewhere in the proof, you will say definition of midpoint, definition of an angle bisector, for example, definition of a perpendicular bisector, definition of congruent segment. So all the words we've learned definitions of can be used in proofs now, okay? All right, so first of all, the given, they wrote it down and they marked it, so we don't have to worry about that. If they don't put it in the picture, you'll have to write it in. Now, we do need to talk about what does this mean and maybe add some markings. It says ray LM bisects angle KLN. What kind of markings can I add in if it's a bisector? Marquise?
Congruent lines.
Congruent what?
Congruent lines.
Markings, yes, congruent markings, but where? On segments, angles?
On both sides of the angle.
Good, on both sides of the angles. This ray is cutting this angle into two congruent angles. So this angle is congruent to this angle. Now, those markings need to be stated in the proof. All right, so the definition of an angle bisector is that it divides an angle into two congruent angles, if you look back in your notes. So we marked them. Now I'm going to write this in my proof. Line 2 will say that angle KLM is congruent to angle NLM or MLN. It doesn't matter which order you do, okay, as long as you have L in the middle. You have to say congruent. not equal. Okay, why? That is the definition of an angle bisector. So this is our definition of an angle bisector. And you will see me like abbreviate with an angle symbol instead of writing angle. So if you want to do that, you can. But if you look back in your notes, when we actually defined the word, it said, an angle bisector is a ray or a line that divides an angle into two congruent angles. You have to state that they're congruent. Okay? Now, before I can substitute in what I know these things are, you first have to go from congruence to an equal sign, because right now we don't have one. Okay? So from step 2 to 3, all we're going to convert to is from a congruent sign to an equal sign. And with angles, when you do that, you're going to have to throw in that little measure in front. So we will say the measure of angle KLM is equal to the measure of angle MLN. The measure of an angle equals the measure of an angle. Any guesses on why I'm allowed to do that? It is a definition. Any guesses? What does congruent mean? Something's congruent.
Similar? Same?
Not just similar. The same, what's the same about them? So if two angles are congruent, what's the same about them?
The measurements are equal.
The measurements are equal. So the definition of congruent angles is that they have equal measure. If they're congruent, each of them is 30 and 30 or 40 and 40. So this is the definition of congruence, okay? And you could use the congruent symbol, but I do want you to write either angles or segments. We're talking about angles, so this would be the definition of congruent angles. Congruent angles have the same measurement or equal measurement. These are the two steps that a lot of students will forget one of these. Okay. Now that we have an equal sign, we can substitute in what they told me. Now be careful. They told me MLN first. They told me KLM second. So just be careful that you do keep everything. I know in algebra you could just plug in anything on either side. You have to be really neat and orderly. So KLM was 2x plus 40. MLN is 4x. And again, we substituted. That's our substitution property of equality. Now, some of you, when you solve this by hand, you like move things from one side to the other in your head. You can't do that in a proof. Okay, so you'll notice that there's 7 lines. Most of you would solve it in 6 just by using a property to switch everything around. But since the x is already over here, I would usually subtract 2x on both sides. So I would have on line 5, 40 equals 2x. What did I do to get there? I subtracted, so that's my subtraction property. See how close subtraction and substitution look? You should be careful if you abbreviate either of those. Then I know we would divide by 2. And most of you would write x equals 20. You can't do that yet. Right now, 20 is on the left, x is on the right. So you have to have 20 equals x first. What did I do? I divided. That's the division property. And I know it seems obnoxious, but we do have to flip it around using that property I talked about on the front of the notes. Does anyone remember which property? No?
What's the property?
Close. Not reflexive would be 20 equals 20, or x equals x. Aaron? Symmetric. Symmetric allows you to flip it. Now, on the next page, we are going to learn there's a symmetric property of equality and of congruence. So you do actually have to put of equality here. I know it sounds obnoxious. I'm sorry. It is. Okay. Last page, then, we have our properties of congruence. They're the same ones we talked about on the front, reflexive, symmetric, transitive. The only difference, they have a congruent sign instead of an equal sign. Okay? So the reflexive property of congruence says that, again, the same segment is congruent to itself because they are the same segment. Okay? Symmetric is the one where you can flip them. And transitive is the one that was like the law of syllogism. It's like a train. If AB is congruent to CD and CD is congruent to EF, then we can say that AB is also congruent to EF. And you can do this with more than 3 things. Like you could have if X equals Y and Y equals Z and Z equals A, then X equals A. Like you can have more than 3. You could have 10 things, as long as they have that common link that's linking them to the next one. Okay. Now, some people, instead of transitive for equality, will use substitution. Those are kind of interchangeable. What I want you guys to do is I want you to look through these and see if you can name these are all properties. So it's either addition property, symmetric property, transitive property. But make sure that you put either of equality or of congruence. Okay, I'm going to give you guys a few minutes to try them. If you don't know one, just skip over and come back to it. But see if you can name them. Look back at your notes, and then we'll pair share while I'm passing out. What did they do on both sides here? They subtracted x to get 2x. That's how they got 4 equals 2x. So that's the subtraction property. And that is a property of equality. Sorry to be annoying, but you have to write that. Okay, how about C? What did you pick for that? P is congruent to Q, Q is congruent to R is congruent to S, then P is congruent to S. What property allows me to link all those things together with congruence? Jeremiah?
Transitive property of congruence.
Good. This is our transitive property of congruence. And I think of transitive, I kind of help us to remember like a train, like they're all linked together. D, angle K is congruent to angle K. Maddie? Reflexive property of congruence. E, Marquise?
Addition property of equality.
Good, they added 8 to both sides, so that's our addition property. And that's of equality. Last one should be also transitive, right? What did you guys pick for A? Brett?
Transitive property of equality.
It's not. In order for it to be transitive, this would have to be x equals y, y equals something. Like the middle link has to be exactly the same, and it's not. There's no matching exactly. Marquise? It is substitution. So what changed from here to here is that this y magically became an x. What allows you to do that? Well, if x is equal to y, you can substitute x in for y. So this was the substitution property of equality. All right, homework's coming out to you. I guess we don't have time to go over the quizzes. So just put them in your quiz folder and pass them up. And then tomorrow, you guys are going to be practicing some of the proof stuff, so I'll pass the folders back out, and if you guys want to ask me individual questions, we can.